All right, friends, welcome to science. I saw the message in the chat that some of your the link to the video is not working for you guys in Echo. That is okay. Just pay close attention to the lesson today. I will also go back in and make sure I check that that link after our lesson together. I'm not going to waste our time together to do that, but I will go back and check it and update it or fix it if I need to. If not, we're going to cover everything that the video covers so that you should be able to do your assignment without the video. So don't sweat it if it's not working. If you did not get a chance to check in, please check in with me. I did not get very many people checking in, probably about 7 or 8 from each class. That means 10 of you in each of the classes did not check in with me, and I definitely need to know where you are. If you've already checked in, thank you. But I need to know how comfortable you are with heat transfer. No, I'm not going to make you teach someone else, but if you could teach someone else, I just want to know kind of where you feel as far as your comfort level. And remember, if you've already checked in, please do not check in again so that I'm not like repeating numbers here. All right. Thank you, Joshua. Okay. All right. Thank you, Lee and Zariah. Genesis, are you with us? I didn't get a number for you, sweetie. Didn't get a number for you, Jacaden? Nellie? Didn't get a number for you. I need you guys to go ahead and check in. Oh, maybe Mark, Nellie, and she's not here, maybe? Thank you, Genesis. All right, friends. We're going to go ahead and get started. And I'm recording the lesson, so please make sure that you are on your best behavior. All right, let's go. All right, so please do not forget, we have STAR testing today. So if your name is on this list, you need to stay after for science. And Ms. Chalfant or Ms. Zelinsky, any of the kids who are not here, but they're on this list, could you please send them an email and get them to join us ASAP? Thanks, ladies. All right, next up on our things to do today, we gotta have a talk. Friends, do I really need to figure out who's doing this and turn on the names? Because I will be glad to. I'll be glad to get in touch with your parents to let them know that you're not using our class time wisely. I'm going to trust that I have 5th graders who are going to make awesome choices. So that being said, many of you are missing work in science. I provided feedback on all of the assignments that I have received as of 3 o'clock yesterday. So please check your to-do lists in Echo. If an assignment is showing up and you are sure that you've already done it, look beside of it and it's going to have a little arrow, 100% positive, and that arrow is going to look something. Hold on, I'm drawing it. It's going to look like this. And that means that I have sent it back to you for you to redo because maybe you didn't follow directions, or maybe you just typed something in and submitted the assignment so that you could get that green check because you were in a hurry that day. I'm giving you guys another opportunity to get the score that you deserve and show me that you know what we've been talking about. I'm sure all of you know what we've been talking about, and this could be really easy and quick for you. So, you know, if you figure you waste a minute just like submitting the assignment and then I send it back, and then you waste another minute trying to find another way to submit the assignment and I send it back. Guys, those minutes add up. Just do it right the first time and we'll all be happy. All right, next up on my list is conduction. So, how many ways can you describe conduction? So that's what we are going to talk about today. And by the end of this lesson, you guys will be able to show me or tell me about many ways that conduction can occur and what it looks like. Alrighty, so conduction is the transfer of heat by direct contact or touch. Another way that I have taught my students in the past to remember it is con-touch-shun. We know that that suffix at the end of the word, T-I-O-N, says shun. So con-touch-shun is the transfer of heat by touch. The two objects have to be touching in order for the heat to be transferred. Because it happens when the molecules collide with the other molecules. And the only way for them to collide is for them to touch. All right, so all of you in your handy dandy little palms, I want you to hold your hand out like this and imagine that you're holding an ice cube in your hand. The faster moving molecules in your hand bump against the slower moving molecules in the cold ice cube. Now, do I have any clever scientists who would like to tell me what is going to happen if I put slow-moving cold ice molecules on my warm, fast-moving moleculed hand? Let me look for my participants. All righty. Harlem, what's going to happen?
What is going to happen is the hand is going to heat up the ice cube and slowly melt it.
Yes, my hand will heat up the ice cube and it will slowly melt it. Other words, heat energy from my hand will move into the ice cube and will cause the molecules in the ice to move faster. So then it changes from a solid to a liquid because the molecules start moving a little bit crazier and spreading out a little bit more. So the ice starts to melt, and in turn, the molecules in my hand are going to start moving slower because the heat is being transferred out of the hand, right? So that's why it feels like your hand gets cold when you put ice on it, and that's because the warmth from your hand is transferred into the ice cube. The ice cube does not cool your hand down. Your hand warms the ice cube up, which in turn makes your hand a little bit cooler because the heat has been transferred out of it. So keep that in mind. That is very, very, very important. And I'm seeing a couple more people checked in with me, so I want to make sure that I put those numbers down on my handy-dandy sheet so I don't forget. All right, so conduction usually occurs most easily in solids and liquids. And we normally we see it in solids, but I gave you the example of the liquids in our heat transfer observation that we did last week. And it usually occurs in liquids and solids because the molecules are closer together. In gases, the molecules are so spread out that it's hard for conduction to happen. Which is, then you have convection, because convection is air, but we'll talk about that tomorrow. All right. So here we're going to watch a little video about the conduction of heat. And as we are watching this video, I want you to think about these two questions. What is conduction in your own words? And what is an example of how you've experienced conduction? And I'm going to go ahead and lower the hands of you lovely ladies who I think had your hands up for the last little bit. That way I've got a fresh start. Here we go.
Conduction of heat. This video talks about the conduction of heat. Let's perform an activity to understand the conduction of heat. Take a straight and flat rod of aluminum or iron to fix some nails using wax. Fix the rod to a stand. Now, heat the other end of the rod with a spirit lamp. Absorb the order in which the nails drop down. The nail near the spirit lamp falls down first, followed by its nearest neighbor, and so on. The one near the stand falls down last. The heat supplied by the spirit lamp flows to the other end of the rod by conduction. We know that in solids, molecules are closely packed, touching one another. When heat is supplied to one end of the rod, the molecules absorb the heat and begin to vibrate vigorously. These vibrations are passed on to the neighboring molecules and make them also vibrate. This phenomenon is repeated throughout the length of the rod. In this way, the heat energy gets transferred from the hot region to the cold region. Transmission of heat in solid substances takes place through conduction. For the conduction to take place from the hot portion of the body to the cold part of it, or from the hot body to the cold body, the two parts should be in contact with each other. When the temperatures of these bodies are equal, the flow of heat through conduction process stops. We can observe this phenomenon while using a thermometer. When the bulb of the thermometer touches a hot substance, the mercury absorbs the heat and it expands. When the temperature of the tip of the thermometer and the substance are equal, no transfer of heat takes place. So, the level of mercury does not increase further. Two conditions are to be fulfilled to transfer heat from one object to another by conduction. They are: 1. The two objects must be touching each other. 2. There should be some difference in the temperature of the two objects. Heat transfers from the object at a high temperature to the other, which is at a low temperature. When a teaspoon is put in a cup of hot water, these two conditions are fulfilled. Water and the spoon are touching each other. The temperatures are different. So the cold spoon absorbs the heat from the hot water, and so its temperature rises.
All right, friends. So who can tell me what is conduction? You can either use the example they give you in the video, or you can tell me what it is based on either what I've told you or what you've learned through the songs or through last week. All right, Kaylee.
Conduction is the flow of heat transfer from when a hot object is touching the cooler object, and then the hot object is conducting heat to the cooler object.
Excellent job. And I'm so very thankful that you said a couple of times that it's transferred through touch from the hot object to the cooler object. Fantastic job. Now, Cammie, can you give me an example of when you've experienced conduction?
A time that I have experienced conduction was when one time I was cooking chicken noodle soup in a mug in the microwave, and I didn't think about it at the time, but I was really cold, by the way. But pretty much what happened was I didn't think about, oh, this cup is going to be really hot when I take it out of the microwave. Fun fact, we actually had been at a beach house and the same thing happened, just more broken glass than what happened to me. So pretty much what happened was I went into the microwave and I went to grab the cup. Thankfully I didn't get it out because I would have dropped it like my brother did. So the cup was not broken or anything, but when I touched it, it burnt my hand, and I actually have a scar on my knuckle from it. It really hurt, and that's when I experienced conduction, because as soon as I touched it, it was like an instant burn because the heat transferred.
Yes, excellent job. I love that instant burn because the heat transferred so fast, and I'm sure there was a great difference between the temperature of your hand and that mug that had been heating up in the microwave. Excellent job. Laylan, tell me about a time when you've experienced conduction.
A time that I experienced conduction was when I was helping my mom and my dad and my sister and brother make dinner, and we were making spaghetti, and so they told me to pour out the water from out of the noodles, and the boiling water poured on my hand, and it was really hot, so I had to put cold water on top to cool it down. And when I poured out the noodles, all the heat transferred to my hand.
Oh, yeah. So the heat was transferred from the noodles, from the hot noodles, to your hand, which was cooler than the noodles that had been cooking. Excellent job. Let's see, Genesis. Tell me about a time when you've experienced conduction.
So I actually wasn't thinking my food was that hot, but it burned my tongue.
Oh
And I
my
had-
goodness. Tell me more.
I didn't think it was gonna be hot, but it was hot.
Yes. Oh my gosh. I am sure that every single person who is in this Zoom room right now can say that they have experienced conduction by trying to eat something that was too hot and burned their mouth. Absolutely. Thank you for that example. Now, I am going to ask for more examples later on. So if you did not get a chance to share, don't like sweat it too bad. You're definitely going to get a chance to share at the end of the lesson. So make sure that you kind of store that away or jot a quick note down so that you can share that here later. Or if you weren't ready to share yet, kind of keep that in the back of your mind. When is the time when heat has transferred through touch sometime in my life? It probably happens at least every day, somehow or some way. I have heat transfer by conduction when I curl my hair with my wand in the mornings because my hot wand is touching my hair. And sometimes I accidentally touch my hand, and that is not the conduction that I'm looking for.
Miss Chadwick, the kindergarten teacher, please call the front office. Miss Chadwick,
Okay.
kindergarten teacher.
Also, friends, we also have like when we're cooking bacon on a hot pan, maybe when we're cooking pancakes on a griddle. And for those of you that, have either completed your assignment or have taken a sneak peek, you'll see that Bash is actually cooking pancakes in the example that I gave you for your assignment today. Burning your tongue, like Genesis said, ice cube melting in the hand, like I said earlier, and your feet touching the cold tile floor, maybe like a cold wood floor. So keep thinking of those types of things because I want you to share at the end of class. So we're gonna go ahead and skip over here because this is pretty much the same thing all over again. Except that example there, this example here is a little different. There's actually, you've got your cup of hot cocoa and the spoon is in the hot cocoa. So you have conduction occurring there with the spoon touching the hot cocoa. But another example of conduction that's occurring here is also the heat being transferred through the spoon. So the whole spoon is not touching the hot cocoa, but the heat will transfer up the spoon because it's a metal spoon, and it will continue to conduct the heat all the way up to the tip of the spoon if the liquid is hot enough to have enough heat to transfer out and up the spoon. So there's actually two types of conduction occurring there. All right, friends, so we are going to try a new activity today. If it doesn't work, then we're going to just try it another way some other time. But I found out about a new tech tool. It's called Jamboard, and I'm going to experiment with you guys today to see how it works. So let me actually go back and share my screen again because I need to exit the presentation so that I can get the code to share with you. I'm going to post a code down in the chat box. Not a code, a link. I'm going to post a link in the chat box. I want for you to click on that link, and it's going to take you to a Jamboard. Please do not do anything until you watch my example here in just a second. Oh, Bash cooked the pancakes. He's a little cook all the time. All right, so do not click this link yet. I'm going to click the link though. Okay. And I want everybody to follow along because on this Jamboard, you are going to have 3 different questions. Somebody click the link. You're not following my instructions. You should not be clicking the link. Amelia, come back to Zoom. Come back. Do not click the link. Okay. So when you click the link, it's going to take you to the Jamboard. Over to the left-hand side is your tools. Now, you guys are going to have a plus sign down here. It's going to have, Ansley, come back to Zoom. You should not click the link. You couldn't resist. Okay, So there's going to be a plus sign, and you're actually going to be able to add a sticker because it's an iPad feature, not a computer feature. But you can add a sticker, and I want you to put a sticker in whichever answer choice you think is correct. So your first question only has 3 answer choices. Your second and third question have 4 answer choices, so please just make sure you don't put the sticker on top of the question because everybody needs to be able to read the question. So now you guys can click the link, and if you have any questions, unmute yourself or raise your hand, and I'll call on you, and we can get it figured out. Ready? Go. We're adding stickers to what we think our answer is. Cammy's here. Naha's here. We're jamming, y'all. Oh, gracious. No, you're not following my instructions. Not following the instructions. The instructions did not say touch the background. It said to go to the bottom and add a sticker, friends. Nope, can't answer that.
Miss Hernandez,
Yes.
it won't let me because there's too many people.
It won't let you into the jam?
Yeah.
Okay. So right now, I've got lots of friends who are moving the background. I need for you to move it.
I don't know what to do. You join.
Emmett, you're on the background.
It's not letting me do it too. It's saying that there's too many people on it for me to view. Come back later.
Okay, that is fine. We're gonna get the people who are in here to add their stickers, like I have asked them to, and then they'll pop out, and then you guys can join. Really, guys?
There's not even a background anymore.
Yes, I know. I have just go to all right, everybody come back. I'm going to remove rights on the Jamboard because we can't follow directions. We will try that again another day.
Hey, Miss Hernandez. Yeah, I couldn't even add my sticker. I don't know how to add a sticker anyway.
Okay, it's fine. We'll try it another day.
Did I miss anything?
Nope, you didn't miss anything. All right, so we're going to come back to the presentation together, and we're just going to look at the questions together. All right, so we have which is an example of conduction. We have A, steam is rising from a cup of hot coffee. A hot biscuit is warming the plate it is on, or the sun is shining through a window and warming a table. Which of these is an example of heat being transferred through touch? Respond in the chat. All right, got lots of friends responding. Reagan, can you explain to me which answer you chose and why?
I chose B because the biscuit is hot. So if the plate is cold, the biscuit can transfer the heat to the hot plate.
Okay. Ella, would you like to add to what Reagan said?
No.
No? Okay. So yes, the hot biscuit is going to warm the plate if there's a temperature difference, but how do we know that this is conduction transferring through touch? Lily, how do we know that this is conduction?
Because the biscuit is hot and like you're putting it on the cold plate, and then when the biscuit touches the plate, it gets warmer.
Yes, it is on the plate. That's what I was looking for. It is on the plate. We have a temperature difference and it is touching the plate. So that's what we're looking for when we're identifying what type of heat transfer is happening. Excellent job. Let's do this one. A boy touches a stove and gets burned. What transfer of heat caused his hand to get burned? Real quick. This should be 100%. Everybody gets it right. Let's go. Quick. 5 seconds. 5, 4, 3, 2, 1. Awesome. 100% correct. Love it. All right. Next, which best explains how ice melts in a person's hand? The heat from the person's hand transfers by radiation to the ice, causing it to melt. The heat from the person's hand transfers by conduction to the ice, causing it to melt. The cool temperature of the ice transfers by radiation to a person's hand, cooling it off. Or the cool temperature of the ice transfers by conduction. All right, we're torn here. We're torn, it looks like, between A and B. We're torn between heat from the person's hand transferring by radiation and by conduction. Alicia, why do you think it is A?
Because I think it's A because of the rate of the radiation that's heating the ice to make it melt.
Okay. And what is radiating? What is radiating the heat and making the ice melt?
The heat is basically the heat from the radiation is like conduction, but not like it's not conduction. So it's basically heating it down to make it melt and make it watery.
Okay. I'm kind of hearing in your response you going back and forth between answer choice A and B in your explanation. So let's see. Joshua McGovern, can you explain to me why you chose B?
I chose B because if the person's hand is transferring by conduction to the ice, causing it to melt, because conduction is direct touch.
Perfect. Yes. So if the ice was just like setting over the person's hand and heat was radiating up from their hand, causing the ice to melt, then that would be radiation. But with this one, it says how ice melts in a person's hand. That means that the ice is resting on their hand. So we have that direct touch there. So since we have the direct touch, like Joshua mentioned, then yes, we have conduction. So heat is being transferred from the hand to the ice through direct touch. Excellent job. All right, so we're almost done. I only have 3 more slides to go over with you guys. Well, really 2, and then 1 more reminder slide. So we have here some examples of conduction. We have a hot iron, ironing some clothes. We've got hot cocoa, a camp stove, and snow. So we have an example up top that says the cookie sheet transfers thermal energy to the cookies and helps them bake. There are many other common examples of conduction. So the first example I'm going to give to you, and then I want for you to raise your hand if you can complete this sentence for me. So we're going to look at the hot iron here. We have thermal energy is transferred by conduction from the hot iron to the shirt because it is on the shirt, right? So now I want for you to raise your hand if you can complete this sentence for me by either using examples that's on your screen or maybe your personal examples that you were going to share with me earlier. So thermal energy or heat, thermal energy is transferred by conduction from this to that. So like Genesis' example from earlier would have been thermal energy is transferred by conduction from the hot food to my cool mouth. Okay? All right, let me look for some hands. Where your hands at? Oh, I got rid of my example. Sorry, guys. It's coming back. I'm having lots of problems with technology today. All right, that was not the button I was looking for. Let me find my hands. Where's all my hands? There's my hands. Where my hands at? All right, Alicia, please remember we are not drawing on the screen. All right, Ansley, go ahead. Ansley, are you there?
It started glitching when you. What'd you say again?
I was just looking for your example for heat transfer through conduction. You're going to complete the sentence. Thermal energy is transferred by conduction from the blank to the blank.
It could be transferred through heat and sorry.
I can come back. Josiah, do you have an example to complete that sentence?
I do not have that example.
Okay. Did you have a question?
No.
Okay. All right. Ella, can you complete the sentence? Thermal energy is transferred by conduction from the blank to blank.
Thermal energy is transferred by conduction from the toaster to my thumb.
Oh, yes. If you get burned by your toaster, absolutely. It is transferred from the toaster to your thumb, and that does not feel nice. Excellent job. Samira, can you complete that sentence for me? Thermal energy is transferred by conduction from the blank to the blank.
Thermal energy is transferred by conduction from the person to the other person.
Okay, so maybe if someone is cold and you embrace them and try to warm them up, then yes, it could be transferred from the warm person to the cold person. Excellent job. Naha.
Thermal energy is transferred by conduction from the hot food to the roof of my mouth.
Yes, ouch. Definitely. It could definitely be transferred by conduction that way. Kaylee.
Thermal energy is transferred by conduction from the hot pan to my hand.
Ouch, yes. And that does not feel nice either. All right, Aunt Ansley, our last sentence.
The thermal energy is transferred from the stove to, say, if something spilt, it could have gone to my foot or my leg.
Okay.
So it could have gone from the liquid inside the stove onto me.
Yes, so thermal energy is transferred by conduction from the hot liquid to my leg. Absolutely. If it spilled, absolutely. Perfect example. All right, so your assignment in Echo today is an at-home scavenger hunt, and you all are going to be finding an example of heat energy happening around your house some way. You've got to find an example of conduction in your home. You're going to mark up the picture to illustrate the transfer of energy. So as you guys will see here, whoops, that was not what I was looking for. Let me zoom in. All right, you will see the arrows. The heat is being transferred from the burner to the pan. Also, heat is being transferred from the pan. So the arrow starts at the pan to the pancake. So then it points to the pancake. That is what your assignment tells you to do. It tells you to illustrate the transfer of energy. And then you're going to label it, and you're going to submit your picture, annotating the transfer of energy on it.